Chapter 2, Section 4 is about solving equations that have a variable on both sides. And remember, when we say sides, we are talking about on like the left and the right of the equal sign. Now, a lot of these steps, you've already seen them because you've been doing some of this work in the previous sections where we've been solving equations. The big difference here is that you may have the letter that you're trying to solve for on the left and the right side of the equation. And so in order to solve problems that look like that, we will need to get all of the like terms together. So first thing you want to do is make sure again that all of your terms are still being separated by addition or subtraction only. Clear any parentheses that you might see, clear division bars, using like multiplication, your distributive property, and then combine like terms if you need to. Then what you're going to do is start moving terms around. So a lot of times we want to try to get the items that have the variable onto the left side so that we get that letter X or Y or whatever it might be on the left side of the equal sign, and then have the number be on the other side of the equal sign. So have the number be on the right side. A lot of times that's done with adding or subtracting terms and combining them together. Then once you've gotten those separated, you want to get the variable term by itself. So if you need to move numbers over from the left-hand side to the right-hand side, you want to do that next. And then finally, if you need to divide or multiply by something to get that variable term all alone, that would be your final step for you to be finished with the problem. So let's take a look at this first example here together. So for this first one, what I would do to start is get rid of the parentheses by distributing that 3. So that it says 12x plus 18 equals 2x plus 8. Then you're going to want to get your letters and your numbers together. So I've got the 12x and I see a 2x on the right hand side, and I need to get those to be combined. So what I'm going to do is subtract 2x. And remember, you always do the opposite sign of what the term is. So since there's nothing written in front of the 2x, there's no negative here, that means that it's positive to start. So I'm going to subtract 2x from the 12x. Over here on the right, those two x's are going to cancel each other off. I have 12x minus 2x, which would be 10x, and then bring down the plus 18, bring down the equal sign, and bring down the 8. Then we need to move that positive 18 over by subtracting it, so minus 18 on both sides. So again, the 18s cancel, bring down 10x, bring down the equal sign, and then you have 8 minus 18, which would be negative 10. And the last step is, because we still don't have x by itself, is get rid of that 10, and we do that by dividing both sides by 10. So we get x equals a negative 1. So go ahead and pause the video here and try to do this practice problem on your own. So first thing we should do is distribute the 4. So it says 24x minus 8 equals 2x plus 80. Then I would have subtracted this 2x from the 24x. So that's 22x minus 8 equals, bring down that 80. Then I'm going to add 8 over to the 80. Bring down the 22x. Now that's equal to 88. Divide by 22. And so we get x equals 4. Now, for this next problem, it's very similar in that we've got variables on both sides, just like we had up on those previous ones. And don't let the fact that they put fractions in here make you think that you're going to have to do anything different as far as the beginning steps for trying to get the like terms together. So I still want to get those m terms together. I still want to get my regular numbers together. So to get me started on this one, I'm actually going to subtract the 4/5 m on both sides. So those are going to cancel each other off over there on the right. Now 6/5 minus 4/5 is going to be 2/5, and then m, and then I have plus 8 equals, bring down what's left over here, which is a minus or a negative 10. Don't forget to bring down that negative sign with it. Now I'm going to subtract 8. So I've got this 2/5 m, and I'm going to bring this up here so I have a little bit more room. So 2/5 m is left on the left-hand side. My positive 8 and negative 8 have canceled. I bring down the equal sign. Be really careful here because it's negative 10 minus 8. So that would actually be negative 18 when I combine those. Now, back in section 2, when we were solving one-step equations, we discussed this case when you have a fraction sitting in front of a letter. Right now it's being multiplied, so the big temptation is, well, let's divide by that 2/5. But remember we said in class that dividing a fraction by another fraction can be really complicated. So we don't want to do that. Instead, we want to use the reciprocal of 2/5 to help us get rid of it. So what I'm going to do is multiply both sides by the 5/2. So those will cancel. So that'll get me my m by itself. And then over here, if we take negative 18 times 5/2, that's going to simplify to negative 45. So, like before, what I want you guys to do right now is pause the video here and try to do that practice problem on your own. So the first thing that I did for this one is I actually subtracted the 1/2 p from the 3/4. Now you don't have to go this way. You could have subtracted the 3/4 over if you wanted to instead. The only reason why I'm doing this is because it's going to help keep my p positive. So that's why I moved it over to the right side instead of moving it over to the left. So I'm bringing down that negative 15 and the equal sign. So 3/4 minus 1/2 is going to be a 1/4 p, and then we bring down minus 3. Then I would have added 3 over here to the negative 15. So that would be negative 12 equals 1/4 p. And the last step is to get rid of that fraction. And so to do that, you need to multiply by the reciprocal, which would be 4/1 or 4. So I'm going to multiply both sides by 4. And that got p equaled negative 48. Now, on this last page here, these are called special cases. So I want to go over these ones together so that if you ever run across one of these on a homework assignment or an accountability check or something in the future, you know what it means and you know how to handle it. So for this one, I'm going to start by distributing that 2 to get rid of those parentheses. And so it says 6x minus 16. And then bring down equals 6x plus 5. Now, right away, some of you may notice that there's a 6x here and there's a 6x here. But the x's are the same on either side of the equal sign. Now, what's going to happen is if I try to move 6x by subtracting it from one of the sides, it doesn't really matter which side I try to subtract from. On both sides here, you're going to have a positive 6x and a minus 6x. So these are both going to cancel each other off. They're both going to cancel out. And you're left with negative 16, an equal sign, and a 5. Well, negative 16 does not equal 5. Those are not the same thing. So if that happens on a problem where your x terms have canceled each other off and you're left with these two numbers and they are not the same thing, we would have to say that this has no solution. What that means is that there is no value for x that I could put into that equation and have it work. So there's no number I can put in for x that's going to balance the equation out and have the left side equal the right side. Those two equations up there are just never going to be equal to each other. So this one has no solution to it. Now the second special case, we're going to start the same way. We're going to distribute to begin. This time though I need to make sure I distribute 2 times because I've got parentheses on the left and the right side. So it says 4x minus 12 equals 4x minus 12. Now if you look at this one, they're the exact same equation on both sides. Again, my x terms match, but so do the negative 12s. Okay? If I wanted to try to do like I did on that previous example and get my x's together by subtracting them, they're going to cancel off on both sides, just like up above did. But when I pull down what's left, it says negative 12 equals negative 12. Now this one's true, because those are the same numbers. So when I saw up here that they were the exact same equation, and when I simplified it a little bit here, I got negative 12 equals negative 12. This doesn't mean no solution. This actually tells us that this problem would have infinite solutions. Infinite, if something is considered infinite, it means that it goes on forever. Like infinity, the number infinity represents how numbers always continue to get bigger or get smaller over time. So this has an infinite number of solutions. What this means is that I could actually put in any number I wanted to for x and it would work. It would be equal no matter what x value I put in to that problem.